All right, let's get started. We've got a quiz in 2 days. The quiz is over chapter 13, the parts that we covered, chapter 10 for inventory models, and chapter 1, the parts we covered. So let's see what to say. So Thursday we talked about formulating equations from reading a story, and then we got into solving break-even points from reading a story and pulling the information. But before we get more into chapter 1, I want to make sure you see the spreadsheet I posted about a week ago from chapter 10. And in the spreadsheet, I did the calculations using cell locations for calculating all these for the EOQ model. Here's the production lot size, which is not complete. Here's shortages, and I don't think there's the discounts. I don't think that was on there. But I want to show you how I did it. So I'm thinking, if for any reason, you have to have the internet shut off, and you could have this Excel spreadsheet open. And if you have an inventory question, even though you're supposed to show the setup, you can still use this software to check your answer if you have enough time. But don't forget, most of the points are in that setup and showing some work than just having the right answer. Your concern for having the right answer should be far less than that you're using the right numbers for all the variables. And the biggest mistake I saw in the homework was making sure you convert demand to annual. That was one of the bigger mistakes. The other classes are bigger than you. So, but meanwhile, let me show you how I did this. I used cell locations. So I just had the PowerPoint open, and I went to the formula, and I said, okay, I want to do optimal quantity, 2 times D, annual demand, times C sub O, which is ordering costs. So I do the cell locations, equals square root, parenthesis, 2 times B3, which is your annual demand, times B4, your ordering cost, divided by B5 is your annual holding rate as a percent. So if somebody's going to enter 10%, 20%, so I'm dividing it by 100 to turn it into a percent, to a decimal. So if it's 20%, that will turn it into 0.2. If it's 10%, it'll be 0.1. Then it gets multiplied by the cost of one item. Now, what if the story said, hey, the holding cost is $1. It doesn't give you a percentage, and you want to use this, you would then have to realize, okay, you could just make this like 100%, and then what I say the holding cost was, instead of the cost per 1 unit, just make this $1, and then that will automatically make, let me go back to the formula, that will automatically make then B5 divided by 100 equals 1 times B6, well, you put in the $1 holding cost, so 1 will end up being used. So you just kind of use logic if it doesn't give you a percentage, what you should do. And then there's your optimal ordering quantity. The parts, by the way, for this EOQ that you need to make sure to be prepared for is the optimal ordering quantity, the total cost for every one, all 4 of them. You've got to know how to do total cost. You know total cost is going to be on your quiz. And probably calculating total cost the way however many they're ordering or making now, and calculating total cost based on your recommendation that they should be either ordering or making a different number to show the difference of how much they save. That's the big deal about inventory is that's where you really are going to, in real life, that's where you're going to make the money, whether you're working for yourself or working for another company, is that by showing how much you can save the company if they change the way they're either ordering this product from a supplier or making it. Then you go to your annual review and you say, look at this idea about changing the way you do this, how much we save, and you get the bigger raises that way. So it's always being able to calculate exactly how much a company will save by changing the way they do this. So holding cost, ordering cost, added together, those are those 2 halves that got to get in balance, is your total annual cost. We did not do maximum inventory level. We did not do average inventory level. That's going to be in operations. Reorder point we did do. And in your notes somewhere it should say the reorder point is always equal to the amount of product that on average we would sell or get rid of during the lead time. Now, the lead time is always the amount of time from when you place an order to the order arriving at your dock. That's the lead time. So it's always however many you go through during the lead time. That's your reorder point. And if you want to see the math on it, there's several ways to calculate, but in this case, is taking B3, your annual demand, which is how many you go through in the whole year, divided by B7, how many days this company's open. Remember, if it's a quiz, it's going to say how many days, but some of these homework problems don't list how long it's open. You must assume all year, 365. But I'll probably always tell you. For example, I think your homework had a problem where it said 300 days. Is that correct? Is that what it was? And so if it says 300 days, you would always, in your calculations, when you're converting demand to annual or production to annual, you would use the amount of days that it says in the problem, 300 days. In this case, if that were that problem and it was EOQ, not making something, but ordering from a supplier with no back order, then you'd put 300 there. Then it says multiply by B8, which is the number of lead times. When you take demand and you divide by the number of days they're open, you're calculating the average amount that they go through in a day. And then lead time, if it says the lead time is 1 week and they're open every day, put 7 then for the number of days. If it says lead time is 8 days, then put 8 days. You've got to make sure that the working time and the lead time are in the same interval of time. If they can both be in months, they can both be in weeks. Most likely they're both going to be in days. So they have to be the same interval of time. You can't have one in days and one in months or weeks. Yes?
So essentially with this, if we were to have this, and when we figured out annual demand and order cost, yada, 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 and remembered nothing else, we could just look at that formula, plug in B3 is,
yeah,
and then just write that out, and then go from there.
If you decide to do it that way and not write the numbers on your test the way it would look if you were writing it right there, then you would need to, once you're done with the test, get my attention, and either I need to get the spreadsheet on a pen drive or I'll have you turn on your internet and email.
Well, no, like I would put, for example, annual demand divided by B7 would be working days per year.
Yeah.
So that has every single
yeah.
So every single formula we will need to figure it out is in this sheet.
Well, if
right
it's EOQ, if you finished it, you'd have every formula you need for production lot size. If you finished it, you'd have every formula you need for shortages.
Oh, it's not finished.
No, I'm showing you how I did this one
gotcha.
in case you want to finish it yourself.
Okay.
So you can see the process I went through to do this one.
Okay.
I have it finished.
Sure. You're just not spoon feeding us.
That's right.
Appreciate it.
Yeah.
Thanks.
You got to put a little effort.
Sure.
All right. So far, this has been one of your easier classes. Don't worry though. I plan on challenging you. I don't want you to think this is going to be too easy. What an easy class I was. I don't think anyone's ever said that by the end. So I don't know. All right. So I'm just showing you so you can put your own together. And the areas I would focus on are only EOQ, total annual cost, which involves the two above, reorder point, and we may have done number of orders per year, but I can't remember, possibly, so that one. And that's it. We didn't do cycle time. We didn't do maximum. We didn't do average. You can leave those off. Why even with probably wouldn't? Unless they're needed for the other ones. Those are not. So, just want to show you. So now, production lot size. You're going, maybe I would like to have this spreadsheet. And I guess if you fill in the numbers and you put all the work in to do these formulas here, and you want to give me this as your work, because I'll see that you did all this and that you're using the right numbers above, I probably would accept this as your work if you think that's easier for you. Just bring it to my attention, what's going on, so I can approve it on the spot while you're getting started.
So instead of writing out, showing our work that way?
Yeah,
this
would probably, because if you truly did all this work right here, it kind of,
Wouldn't that save a lot of time on the...
I would test it also before you did the quiz. I would put in a homework problem that you know the answer, where the answer is posted, and put in the numbers and make sure it's calculating exactly what the answer is calculating to make sure you set it all up correctly.
For sure.
You could break up cells. I can hear him talking already. Break up cells. You take that cell, I'll take this cell, put it all together. If you form a study group, I'm all for it. Do exactly that. Make it happen.
You said if we have a study group, we could just send that to everybody.
Yeah, sure. Don't worry, you'll be challenged. So I'm not worried. I believe it or not, I really truly would hope everybody gets an A. I've never seen it, but I would love it. I'd be the happiest person in the world. Because I'm going to do everything I can to make sure you don't get the A for cheating. I already told you some of the things I'm going to do. Right? When you walk in Thursday, I'm going to have some folders here. I want you to set them up between each one of you. You have a folder on every side. You just kind of pull it back. A couple people have had it before, so they know the folders have been around a long time. walk around, make sure your phone's on airplane mode. I mean, walk around while you're taking it, making sure, you know, you're not getting on web pages and making sure you don't have any previous tests, as long as you're going through your notes, answers. You have PowerPoints on your computer opened up. You have everything on Blackboard opened up that you can have. But then you got to turn off the internet, so get them open and ready to go so you can turn your internet off. So, don't forget, almost every quiz, and for sure the final, is probably going to have an Excel problem on it, including your first quiz, since I have it almost done. I know there's an Excel problem on it. And so, it won't be this, but if this were it, you would see a picture of a spreadsheet, and I might say, using cell locations, now, don't get worried, not this. It won't be this hard on the first quiz. But using cell locations, tell me what you would enter in B13 to find the optimal ordering quantity for this problem, seeing the information above. And so you have to be familiar enough with this. And maybe you have an example open. You can just kind of look at the example or something. To write equal square root, parenthesis, 2 times B3, cell locations are the B3, the B4, the B5. When you see the instructions, use cell locations, that's what it means. Have it grab the information from a cell and bring it. That's what you should expect.
If we were to put everything from chapter 13 in as well, the min-max, regret, and everything, could we use that to show our work for any min-max, regret, all that? As well?
Yeah.
That would be acceptable as well?
You'd have to enter the whole table onto a spreadsheet. Is that what you're talking about, right?
Yeah.
Yeah, you could do that. If you're willing to take all that time to enter that whole spreadsheet in, then use either a max or a min or whatever it is you want to use to show the work. Absolutely, I'll take it. Save it. Don't turn on your internet until the quiz is over. Either I'll use a pen drive to get it, or I'll have you turn it on while I'm with you and you can email it to you.
Okay.
Is anybody else interested in doing that? Maybe it's fine. Okay. Yeah, I know you mentioned before Excel was kind of more your thing. So yeah.
If I can eliminate math that I have to do myself and have something else do the
sure.
math, absolutely.
Amen.
Absolutely.
Get an Excel spreadsheet ready, knowing, I didn't know we had enough time. I'm only sharing this for those who show up today. I'm not posting this, but if you know there's going to be possibly an Excel spreadsheet, maybe you want to get one ready. What's this? I just wrote it down last night off the top of my head, that these are the main subjects I think we covered between the beginning of the semester and the quiz, I think, right? Read your phone out. There you go. There's the quickest way. Read your phone out.
Smart idea.
Chapter 13, there was maxi max, maxi min. You can barely see, so how would I change the contrast? Auto image? Is that better? No. Yeah. No. Apparently tell us an X. Maybe it's not an X. I was going so fast. There. Yeah, maybe that way. Maxi min, mini max regret, EV, right? Expected values, EVPI. Chapter 10, there's 4 of them. The EOQ, you're ordering from a supplier. There's no back order policy. That's EOQ. Production lot size, you're manufacturing something on a machine. Shortages, it mentions that you're thinking about running out. And then quantity discounts. Quantity discounts takes the longest amount of time because you've got to do the EOQ at each price and then total annual cost at each price. So that's why that one takes the longest. And then chapter 1, we learned how to formulate some equations when we read a sentence. We did the break even, today's objective function and constraints. Excel, we talked about max, using max, min, if, break even, using the what if analysis. Now you could have a picture of that. And it may say, what's entered in the cell, or what would you put in the box on break even analysis for this part of the box. Remember that dialog box when I opened up what if analysis? You should be familiar with that a little bit. I believe there's a picture of it in your book, even the what if analysis dialog box. If you want to have it in its open book, you can have it right in front of you, so to remind you, write notes on it or something. EOQ on Excel, we just talked about that today, and absolute value, ABS, whatever's between there is going to use absolute value. We talked about that last week. Those are the things off the top of my head I could remember that we talked about, or about to talk about between the beginning and quiz. So, if you're preparing, this will kind of lead you in the right direction at least. And what's written so far is involved with everything that's been written. I can see the subjects of it. I'm not saying every subject's on the quiz, because it's not. Matter of fact, at this point, we're only heading towards a 50-minute time limit, and I need to pump it up a little bit to get to an hour. And I usually, quizzes are an hour, we'll start within minutes after class is supposed to start. Everybody says, oh, this class goes till 6:45. It's a time limit, it's open book, open note. The only challenge you're gonna have is probably time. If you had all day, everybody here could ace it, because the answer is in front of you for every question. The answer is somewhere in your notes, in your book. You could. Literally, everybody could ace it. The only challenge you have is you gotta be familiar enough where to look for the help and identifying what kind of problem you're reading right then, so you know where to look for the help fast. And how it's gonna refresh your memory, then how to attack. That's the key to preparing for this. And if you went to the back of like chapter 13 or chapter 10, and you read a random problem, somehow or another, without make it so you can't see which chapter it's from and which inventory model it is. That's switched on purpose. I'm just saying, if you were looking, I don't know, maybe one of the problems in the back of the chapter, see how fast you can figure out which inventory model it's talking about. Is that EOQ? Is it production lot size? Is that shortages? And then go to the back. I think all the even ones are in the back. Then you go to the back and see exactly what it was. Was it shortages? Was it EOQ? Do it with another one. Read it real quick. Is that EOQ? Is that shortages? Go to the back. I think all the evens are in the back. Anybody can confirm that if they have a look?
Yeah, it's even.
Even, so you go to the back and look. And if for some reason you want to do an odd problem, email me and I'll send you the answer. I'll just send you the answer to it. But try to communicate with each other if somebody wants to form a study group, because the best time, since this class starts so late, you can actually do it the day of the quiz in the afternoon. All you need is a couple hours. All right, now we got to finish chapter 1. This is it. This is linear programming now. Before we were formulating equations by reading stories. We were pulling information out, figuring out the break-even model maybe on some of them. And now you're doing the same thing, but it's a little different. This is where you're reading the story and forming equations, but they're not break-even equations. Instead, the equations you're forming are called objective functions and constraints. There's one objective function for every problem. Now, it can be reworded, and it could be a different objective function, but one problem has one objective function. It can have unlimited number of constraints. Another word I used to use for constraints is limitations. In the story, it's telling you you're limited to this. Or there's only 1,000 pounds of steel that showed up to the dock for production. There's your limit. You can't go over 1,000 pounds. This work schedule only allows for 1,000 hours of work time in that department. So that department can't go over 1,000. Those are limitations. Those are constraints. So as this is going to start out so simple that you're going to go, oh, this is nothing. It's going to get more difficult after the quiz, though. The stories become not so much obvious, and it's not just maybe 2 variables, and it's not just 2 constraints. And for this first quiz, to start this chapter out, I'm telling you how many variables there are, and what the variables are, and what they represent. Once we get past this first quiz, your goal is to, when you read a story, to determine how many variables there should be, and what the variables should represent. And you can use any letter you want for the variables, and everybody could have different letters, it's fine. But there's only one answer as to how many variables and what they represent. Just use any letter you want. So that's what you got to focus on. What's the unknown that we're trying to get an answer to? What's the limitation called constraint? And then the objective function. And what I want to point out about the objective function is, and you got to put it somewhere in your notes, every objective function always, always, always is either a maximize or a minimize, period. Always. Every objective function is either a maximize or a minimize, and when you're writing out the objective function, it's usually a shortcut, MAX if it's a maximize, MIN if it's a minimize. There's your shortcut. Another thing I want you to write in your notes about objective function is that it never, ever has an equality, a less than equal, greater than equal, or equal. Does not exist in objective functions. And there's at least 20% of you that will have that on your first quiz or something like that, and it doesn't exist. No less than equals, no greater than equals, no equalities of any kind in an objective function. It either has a max or a min instead. The constraints always have an equality, either a less than equal, greater than equal, or equal. The equal is always part of the constraint. So it's either less than equal, greater than equal, or equal. Never just less than, never just greater than. All right? Constraints all. Now those are the things that you're trying to make decisions on are the variables. Now, I found this easy one we're going to start with. All right? I am telling you how many variables, and I'm telling you what the variables are, and I'm telling you what they represent. As we read this problem, X is going to be the number of units that we're going to decide to buy from supplier 1. Y is going to be the number of units we're going to decide to buy from supplier 2. In this very micro, simple problem, we're trying to find the ideal order to place with two different suppliers that have different things involved. Probably the price. Maybe other things, like they can only supply so much and we need so much. So we may have to order from both of them. That's what we're reading. You ready? And while you're reading it, you're trying to say, when we get to something that seems significant, you say to yourself, is that going to be a constraint or is that going to be an objective function? Somewhere in this problem, there's only one objective function, the main objective. That these variables that we're putting in the objective function, something about it. Now, I also want you to notice, X is the number of units. If you need to talk about how much you're going to buy from supplier 1, you've got to take this X and multiply it by the price of buying from supplier 1. That's how you turn it into money. If it's given to you in units, but you want to write it out in the form of money, for example, it says, we have no more than $50,000 for this month's supplies from our suppliers. We're trying to decide how much to buy from supplier 1 and supplier 2, but the variables are how many to buy. But that's the decision, and it says, and you're writing a constraint, the limitation is we only have 50,000. Whatever the price is from supplier 1 times however many, plus however much it costs to buy from supplier 2 times how many, it has to be less than equal 50,000, because the sentence said we have only 50,000 or less to spend on these two suppliers. There's a constraint in how you would write it and turn the variables into dollars, because the limitation was in dollars. The limitation could be in something else, and you've got to somehow figure out how to use these variables to talk about that limitation, whether it's time, money, whatever. They only have so many available, capacity maybe. Here we go. A candy manufacturer buys sugar. So there's what we're buying from the suppliers. From our two suppliers, one calls sugar supplier 1, the other one's sugar supplier 2. The candy manufacturer needs at least 55,000. Now, even though it doesn't read like we have to get 55,000 or less, some people say that's a limitation. Even if it says we need at least 50,000, which means 50,000 or more, that's also a limitation. The limit is we're not going to buy less than 55,000 units. That's the limit. So when we see at least 55,000 units, and we're writing, and we say, oh, that's a constraint, because it's not trying to tell us we're trying to get as much as we can or as little as we can. It's saying that we have to have at least 55,000 units of sugar for production, so we better get at least that much. And so that's going to be a constraint, and it's going to be 55,000 on one side, which almost always should be on the right side of the equality. My question is, the equality itself, talking about that 50,000, do you think it should be a less than equal, a greater than equal, or an equal? Now read that sentence again. Greater than equal, because it says at least 55,000, meaning no less than 55,000. So if you're writing that out in a form of mathematical, that would be greater than equal to, so that we make sure and not order any less. And that's 55,000 units Now on this side, I got to turn our variables into whatever this right side is representing. That's 55,000 units. So when I'm going to write the left side, I'm going to make sure I'm using these variables as units. It's a coincidence that right now they are in units. I don't have to put a number with it at all. It just so happens that X is how many units we're buying, Y is how many units. So now on this side, I got to write the total number of units we're going to buy, because it's got to be greater than 55,000. Since we're only ordering from 2 suppliers, I can take however many we're ordering from that first supplier, which is represented by the number of units, and if I add it to the number of units we're buying from the second supplier, that's our total purchase. And those got to add up to 55,000 or more, at least 55,000. That's how you write a constraint from a sentence. The big hint, at least, no more than, exactly those words is what you got to turn into something like this: greater than equal, less than equal, or equal. When we get to the software after the quiz, it's going to be asking you to enter one of these 3 things. It assumes the equal. You either are going to be entering the greater than symbol, the less than symbol, or the equal than symbol, because it assumes the equals with it, even if you put less than or greater than. So, and it gets entered in the software where the numbers with the variables are entered. This would be a 1 under the variable X. This would be a 1 under the variable Y, because I don't see any number with them, so it means one of them. And then this would be the greater than, where the equality goes, and on the right side would be 55,000. Now it's asking you to write the next constraint. So let's read on. If, or the objective function. The candy manufacturer needs at least 55,000 units of sugar. Supplier 1 can supply up to 36,000 units. Objective function or constraint? Constraint, because it's a limitation. How many? 36,000 units? Now, there's my right-hand side. I'm going to read it again. Supplier 1 can supply up to 36,000 units. Less than equal, greater than equal, or equal? Less than equal, because we cannot order from supplier 1 any more than 36,000 units. We can order 36,000 units or less, but no more than. We need something on the left side that represents the number of units we're ordering from supplier 1. Anybody have anything they think should go here? Anything else? Y is from supplier 2. I like your thinking.
Well, wait, from supplier 1 or supplier 2?
Yeah, it says supplier 1 can supply up to 36,000 units. So just supplier 1, so that's why we're only going to use supplier 1's variable, which this variable represents how many we're going to order from supplier 1. So this is the only thing that would be on the left-hand side, less than equal to 36,000. Supplier 2 can supply up to 26,000 units. Same situation. 26,000 says up to, less than equal, and what would represent what we're ordering from supplier 2? Just the letter Y. Hypothetically, I'm going to reread this. You tell me what needs to change here. This is hypothetical. Supplier 1 can supply up to $36,000 of sugar. What would change here, what's this one here? Is this the one? This does not change at all. It just happens to be in dollars, but this is in units. So we got to read through the problem and say, well, what's the price per unit from supplier 1? Oh, 50 cents, 0.50 times X, however many units, times 50 cents per unit, it's got to be less than equal to $36,000. See how I switched that to money then, as you read it. This is your introduction to what's going to be becoming much more complex. The statements aren't going to jump right out at you, but the basic and how you set it up that I'm showing you now, I'm taking it to the most basic level you can, that just pick the words out, you can almost literally, and then you say to yourself, is this units on the right, is this variable represented in the same type of units? If this is per unit, then this needs to be units. If that's money, then this needs to be converted to money somehow. That's what you got to ask yourself to get these. Taking that back off, because that was just like the thing. Now it says the price per unit supplier 1, which I didn't even look, now I know that would be 5x, is $5 per unit, and the price per unit from supplier 2 is $4.50. This is so easy that right now in your mind, if you're putting this order together, you're going, I don't need linear programming. That's right, because this is so micro and easy. I'm going to order as much as I can from supplier 2, because it's the lowest price, it makes sense. which says right here, it can 26,000 units they can provide. I'm ordering all 26, but I need 55. I subtract the 2. I'm ordering the rest from supplier 1. That's the only choice I have. This is easy. What you're doing in your mind right there is what linear programming does, but it's when you have, in real life, 50 constraints and maybe 10 variables to make decisions on. And you can't just look at it. And this will lead you to the best decision so that money doesn't get thrown down the drain. This will lead you to the most cost-efficient, profitable decision for every one of those variables that you're trying to make a decision on. So $5 from supplier 1, $4.50 from supplier 2. You're going to write up an objective function constraints to solve how much sugar should be purchased from each supplier, which is exactly what we're trying to do, how much, based under these limitations here. And from each supplier, while, here we go, keeping the cost as low as possible. Why did I emphasize that? Because it's your what?
Is it a constraint?
Almost. It's not a limitation. If it said, and keep your costs below $100,000, now it's a constraint. But this just says keep your costs as low as possible. Now I want to give you a big hint. Most objective functions are about maximizing your revenue, maximizing profit, keeping your costs as low as possible, getting finance majors, making the most interest possible for your client, selecting the investments that you're writing a linear programming for, things like that. And so when you see a sentence that says, keeping the cost as low as possible, that's the objective of all this. That's the objective. And you have to write the objective first with the word max or min. Change that sentence, keeping the cost as low as possible. You're the manager. Do you think it's describing something you need to maximize or something you need to minimize? Minimize its cost. M-I-N. Period, I don't even care if you put a period. But I do care if you put the word min or max, because if it's missing, you're probably losing the whole point. That's how important it is that every objective function has either max or min. Next, I need to convert these words, keeping the cost as low as possible, into an expression, a mathematical expression using my variables. My variables are x and y, and almost always, not always, but most of the time, every variable is in the objective function, because they're affecting it in most cases. In almost every case for this class, how's that? Now, I got to convert my variables x and y into minimizing based on the words in the story. And what you need to recognize is, in this very simple problem, that x and y represent how many you're buying, but the objective says keeping my cost, money spent, as low as possible. So this minimization has to have the variables, however many I'm ordering, minimizing the cost. I have to make sure these variables represent the cost. So for every x we're ordering, it's $5. For every y, it's $4.50. Now I am minimizing however many I'm ordering times the cost per unit for each one is what I'm minimizing. And that's what the computer program, or you, I'm going to teach you how to manually solve this, that is exactly what you're going to do. Is it's constantly looking at, okay, we're spending this much, we're spending this much, this has to be as low as possible. It's focused on trying to make sure we're only ordering from this supplier at this lower cost. It realizes we've got to stay under 26,000. Now it's saying, okay, we're buying from this supplier, and that's as low as the cost can get. And it will, then the output will say, it will tell you how many units to buy from X, how many units to buy from Y, and at the top, your objective function value is going to multiply $5 times the recommendation for X, $4.50 times the recommendation for Y, and it will give you at the top your total amount you're going to have to spend to fulfill these requirements. And make sure you have at least $55,000, and make sure you don't order more than 26 from supplier 2, 1,000, and 36,000 from supplier 1. It does all that within a second. It gives you the optimal quantity to order. Very micro, but when this problem's big, this is very handy, huge. This started way back in, I think it was like World War I or II, where they had to make huge tactical decisions for war. And this is how this got invented. There's so many things to take into consideration that they had to break it down to a logical process. What's happening here is this constraint is graphable. This one's graphable. this one's graphable, and then that's graphable, and where the constraints that are those, that can't be going one way or the other, where they cross, right there, at that spot, is your optimal solution. And that's how you manually, way back when I took this class, way back before most of you were born, that's how we had to solve it. We had to literally graph it and figure out where those lines cross. It was a pain in the butt. So, all right. How many? What do we have? We have 3 constraints, 1 objective function. There's never more than 1. Don't be wrong. I can change the wording of this problem. It could change the objective function, but there's still only 1, unless the story changes. And there could be multiple constraints. There could be multiple variables. I gave the variable. If you were reading this on your own without me giving the variables, you're going to say to yourself, okay, what's the decision trying to be made here? It's how much or many I should buy from supplier 1. It's how much or many I should buy from supplier 2. So that's when you then are going to tell me, you could use the letter P and Q. P is the number of units from supplier 1. Q is the number of units from supplier 2. And you have to give the variables and define them. That's where you've got to get to after this first quiz. Let's try another. This is it. This gets a little harder. It's still pretty easy. Finance majors, are you ready? Got a client come in. And you're working for the investment firm and you're managing stock portfolios. The new client says, I want you to start with $50,000 I'm about to give you. And I want the initial investment strategy. The client says, restrict it to the following 2 stocks. I'll leave it up to you, though, how much of each of these stocks to buy. But this is it. For right now, here's my $50,000. You can only get into these 2 stocks. Here's some other things I want to make sure you do. It says, I want you to maximize the total annual return in dollars. Boy, that's a big hint. Is that a constraint or objective function? Objective. Yeah, it almost gives away with the word maximize. So the objective function is giving you a max or min. Maximize the annual return. Then we have 3 constraints. 1 says the total investment funds available. 2 says the maximum IBM investment possible. And 3 is the maximum Netflix investment possible. That's what those letters are, the symbols for those 2 companies. Are you ready? I'm giving you the variables. X is not how much money to invest in IBM, it's how many shares, which does not have to be a 1, 2, 3. It could be 3.2, 3.3. We'll figure that out later. This is how many shares. Y is how many shares in Netflix. I'm giving you the 2 variables. And you've got to convert them to money. You got to figure out how. So let's start with our objective. Now let's start with the first constraint. Total investment funds available. I'm going to erase this. All right. What's the total amount of investment funds available?
50,000.
50,000. So that's going to be our right-hand side. Is the equality going to be less than equal, greater than equal, or equal? Well, hang on a minute.
Less than.
You're handling the 50,000, but if we do have odd number, if it's 100.26 shares, we may buy 100 shares, and a little bit of the money may have to go into a money market account or something as cash, so we may not invest every penny in exactly these 2 stocks. So I see your point. We do have to invest it all, but sometimes it's not possible all the time to get a partial share. We're going to go less than equal to 50,000, because there's no way we can buy more than 50,000 of these stocks. Of course, we'll try to spend as much of the 50,000 as we can. And for the sake of this, we will do point something shares, just so we don't just figure out how much will not be invested. All right, now the left-hand side has to be the variables that represent the amount we can spend. This is in dollars. X is the number of IBM. Y is the number of Netflix. This has to be in dollars, and this is the total amount we're going to buy in shares. So both variables involved, because we're going to buy from both companies maybe. So I'm going to go X plus Y. However many shares we buy for X, however many shares we buy for Y, IBM, Netflix, it's got to be less than equal to $50,000. But this is how many. What number will I put with X to turn it into the money being spent?
8.
The price per share. Wait, where is it?
It's in the middle.
Oh, I thought it was $160? $160 for every share of X, which is IBM, that we buy. Plus we got to spend $130 times however many shares of Netflix we're going to buy. Then now we have the total money being spent less than equal to $50,000. The second constraint, I'll wait for you guys, see some people write it down. Second constraint says maximum IBM investment. What it's trying to tell us is, we look up here, it says IBM, $160 a share, estimated annual return. It's telling us how much money we'll most likely make on this. This is shocking. Plus maximum possible investment. For whatever reason, we can't take more than 42,000 of the 50,000 and invest it in this stock. That's a limitation. $42,000, less than equal, greater than equal, or equal. Less than equal, because we can't go over $42,000. Is that what it is? Dollars. And it's IBM. So on this left side, the variable is only about IBM, which is which variable? X. But X is how many IBM. 42,000 is money. I got to turn X into money that represents IBM. Which, what number? $160 for every share IBM has to be less than equal to $42,000. We cannot spend more than $42,000 IBM. Netflix has the limitation also, 38,000, so I'm putting the 38,000 less than equal. The left-hand side is the variable that represents Netflix, because this is Netflix limitation, which is Y, and we got to turn Y into money, because it's the number of shares in Netflix. So each share is $130 times however many shares in Netflix, cannot go more than $38,000. So let's see, total investment funds, $50,000, maximum IBM, $42,000, maximum Netflix, $38,000. Our objective function is next. You told me max or min, I can't remember.
Max.
Max, because we're maximizing the gain on the investment, I believe. And now I'm maximizing the variables, X plus Y. Well, X and Y is how many of each share. The max, it says to maximize the portfolio annual return in dollars. I have to represent this X and Y as the annual return in dollars based on how many shares we buy. What will be the X? $8 is our expected annual return times however many shares of this stock, plus what's our expected return for Netflix? $7 times however many shares we would buy of that stock is what we're maximizing. No less than equal, no greater than equal, no equal, anywhere in that objective function, and never should ever have one. You just wrote the constraints and the objective function for this investment problem. Simplified, easy investment problem. Very micro, just so you get the idea how to do it. How do we feel? You're going to be given at least one or two, or maybe something like the candy one, maybe. And you need to write the objective function and constraints. But the good news is, however many variables there are and what they represent, I'm giving to you in the problem for this first quiz. So do not use any variables in what you see given to you. It was telling you exactly how many variables and what they represent, literally in the problem. So use those variables exactly. Okay? Oops, sorry.
Oh, I think we asked him the same question. Are these posted on Blackboard?
No. Wait. I don't remember, but if I get home and can remember, I'll post them. And if I don't post them, someone bring it to my attention, I'll post them. But look, the problems don't have the answers on them. Do they? I mean, look, I don't think this has the answer, so you have to connect this to your notes, right? But you just want to be able to read it instead of taking a picture of it right now. I'll just post it. If I forget, they'll remind me, and I'm sure I will. I forget everything. Okay, now I have one that's a little harder. How are we doing on time? Yeah, what time is it? Oh, we got lots of time.
We got a half hour.
Oh my God, we got lots of time. All right, it's going to get a little harder, but is Gabriel walking? There. Where? Okay, just making sure. You write your stuff. Okay. All right, you ready? Make it a little easier. I can't remember if I posted this or not. The problem you're about to read is called Ironworks, but it's in Chapter 1's PowerPoint because it's trying to show you how to turn a problem into objective function and constraints without giving you the numbers when you first read it. So I'm going to put this like, you know what I'm going to do? I'm going to put this on one side. And let me take the PowerPoint. Which one is it? This one? Yeah. And I'll put this on the other side. You see it okay? And so, let me see if I make it a little bigger. No, can't go any bigger than that. As we look at this problem, I want you to see, I'm giving you the numbers. Here we go. Get back here. So we're going to plug in the numbers as we go from this list over here, okay? So it makes more sense. Maybe we want to figure it out on our own before we go to the next slide. See if we can do this. It says, Ironworks manufactures 2 products from steel and just received this month's allocation of blank pounds. Let's see, steel came in. Where's our numbers? Raw material just got delivered 2,000 units, 2,000 pounds, whatever it is. 2,000 units of steel just got delivered. So B, pounds of steel. B is 2,000 units. My question for you is, did we just read an objective function or a constraint?
Constraint.
Constraint. 2,000 pounds got delivered. Less than equal, hang on. Less than equal, greater than equal, or equal to 2,000 pounds?
Less than equal.
Less than equal. We don't have to use all 2,000 pounds in manufacturing. We can let some go to the following manufacturing period. But we can't use more than 2,000 if that's all that got delivered. That's it. We can't go over 2,000. Now, if we had some left over from the previous one, it will say, and 2,000 just got delivered, and there's 120 pounds still available from the previous manufacturing period, or something like that, then this would be 2,120. That's still the most we could use. It's a limitation.
What's an example of what it would say to be equal to?
It will say something like this. It will say, this month's allocation is 200? 2,000 pounds of steel, and every pound has to be used in this manufacturing process. That means you're using exactly 2,000. All right? Now it says, it takes blank pounds of steel to make product 1, and it takes blank pounds of steel to make product 2. So, where is that? Product 1 uses 2 units of steel, and product 2 uses, a little smaller here. Let's go in. And product 2 uses 3 units. So, hang on. We gotta get this where it fits and we can see it. Hang on. How's that? That's pretty close. You ready? There's only 2,000 pounds of steel showed up. We can't use any more than 2,000 pounds of steel. It said that we are making 2 products, and we're calling the 2 products X and Y, X1 and X2, X1 and X2. So here's how many of the first product we're making, plus here's how many of the second product we're making. But this is how many of product 1 that we're using steel on. This is how many of product 2. This is how much in pounds of steel we could use. I got to convert how many into how much steel we're using. So X1 uses how much steel?
2.
So 2 times however many X1s is using of steel. And X2 is using how many units? 3. 3 times however many X2s we're going to make. There's the amount of steel they're going to use, and when you add them together, can't go over 2,000 pounds. Next it says, let X1 and 2 denote this month's production, which right there, I mean, it's hard to see because we haven't read through the whole problem, but really right there, that sentence is literally telling you the decision that has to be made. That this is all about how many of product 1 we're going to make for this next manufacturing cycle, and how many of product 2. And that's the unknown, and if you were doing this after quiz 1, you're the ones got to pick out and go, oh, there's 2 decisions being made. How many of product 1, how many of product 2, you denote variables for each, you define them. P equals the number of product 1, P2 equals the number of product 2. Whatever letters you want to use, however you want to represent it. Then it says, denotes the production level of product 1, product 2, respectively. P1 is the profit, and P2 is the profit that's been estimated that will make off each of those 2 products. And in this case, The profit is, where is it? There it is. Product 1 yields $100 profit. Product 2 yields $200 profit. Right? That's all. We're just identifying that at this point. Ironworks has a contract calling for at least blank units of product 1. All right, let's see, product 1. Ironworks has a contract that requires at least 60 units of product 1 has to go to that customer. No matter what, whatever combination of these products we're making, we've already committed 60 of them of product 1 to that customer. That's a limitation. It says no matter what, we've got to make at least 60 units greater than or equal to, we have to make at least 60 units. And on the left here is how many units we're making of product 1, which is represented by X1. X1 has to be greater than or equal to 60. That's what that sentence says right here. Right? I'll read it again. Ironworks has a contract calling for at least 60 units of product 1 this month. There it is. The firm's facility are such that the most units of product 2 may be produced monthly. There's a limitation. If we ran that machine all month, making product 2, the most we can make is 720 for the month. So no matter what combination we're making, we cannot make more than 720 of product 2 for whatever reason. This is less than equal product 2, which is 720 units. Now here has to represent the amount of product 2 we're making, which is X2. That variable is literally how many of product 2 we're making, and it's got to be less than equal to 720 no matter what, because that's all that we could make in the month.
Would you put the coefficient on those, the 2 and the 3?
Oh, wait, hang on a minute. No, the 2 and the 3 represent how much steel it's using.
Right.
This is how many units it's making, no matter how much steel is available. So there's no 2 or 3. Since this is talking about the number of units produced, the variables themselves already represent the number of units. It is not about how many units of steel it's using or whatever raw material. So we do not put the numbers here. So we have to, like, since this was in pounds of steel, these have to be converted to pounds of steel. Since this is how many units, that's already in the number of units. And same with the 720, that's in the number of units also. The next slide, wait, was that last sentence? Did we get that? Most that we can make, okay. Yeah. Then it said, oh, that's as far as we're going, but it's, hang on, don't look at that. What we didn't pick out of there, we have all our limitations, but what we didn't pick out is the objective function. Now, as you look at that, most objective functions have to do with either profit or cost. So you kind of look through that, and you're managing a manufacturing process. You're at the table, meaning you've been at meetings where it's about, how do we maximize profit? How do we stop wasting money? And your job is to make sure you're scheduling the right amount of these 2 products to be made that will take care of the limitations involved, how much raw material, an order we have in place, and a capacity that the most we can make. These limitations involved. Do you think the objective function is a max or min?
Max.
And what's the maximum related to? What is it you think we're maximizing?
Profit.
Profit, because the profit's given, but it doesn't say it costs this much to make this one, it costs this much, or maybe it would be minimizing the cost. It didn't jump right out like the previous example did, but it is profit. Max, here's both variables, but I gotta convert these variables to profit, because we're maximizing the profit. This is how many of X1, this is how many of product 2, product 1. So this one has profit of $100, is that correct? This one's 200. That's what we're maximizing. There's our objective function. $100 times however many product 1 we schedule, $200 product X2. Now, this is so small that you could literally tell me what the schedule should be next month. You look at that profit, you're trying to maximize it, you're trying to schedule as many of which product as possible. Product 2, because it's going to provide the company with much more profit, twice as much profit for every one of product 2 we can produce. But it says we can't produce more than 720. So we know we're not going to schedule more than 720 of product 2. And we have a contract in place for product 1. So whatever we're scheduling next month for the cycle, we know we have to schedule at least, help me out, 60 of product 1. And I don't see any other limitations other than the pounds. So I'm going to quickly say, what if I schedule exactly 60 and then 720 of these? It's maximizing this, it's staying within this, it's greater than that, and I got to see if these numbers will keep me under 2,000 pounds. If it doesn't, I'm not lowering this one. I have to lower that one to stay within the 2,000, and boom, there's your optimal quantity that you're going to schedule. Matter of fact, if you take 2 times 60, which is 120, subtract 120 from 2,000, which makes 880. Now divide 880 by 3, give me the number.
626.
That's how many we're making of that, 626. And that's how you schedule. What I just did in my mind, I mean, these examples are like that. But that's not where this is heading. You've got to see the fundamentals, how this is done, because they're going to get to where there's no way you're doing it. This is where we're going. When we get to chapter 4, these problems are much bigger, many more constraints, and so I want to make sure you get these basics. People that are out here today, this is such the biggest building block to all the problems you got coming up in the next 3 chapters after this. So how I prepare for the quiz on this one is I would go to the back of chapter 1, maybe pick out a problem towards the beginning of the problems, read it, and the hard part is make sure you're reading one that has an answer in the back because they're not giving you the variables. You'll have to come up with the variables or look in the back to see what the variables are, then write the objective function and constraints, then compare it to the back. If the answer's not in the back, email me, I'll email you the answer. And this is how I prepare for it, is seeing if you can pick out the objective function and constraint on some practice problems so you get a handle on it. Especially forming the objective function and seeing what you got to do to the variables to make it fit the objective. Turn it into money, turn it into weight, turn it into something.
So this quiz we're not solving.
You know how to solve it, not until the next quiz. Next quiz you'll be solving these, absolutely. You have to write them and solve them and come up with the variables yourself. Okay, guys. When you look, real quick.
Smells like propane.
Yeah, there's a solid gas
Right,
there.
Like it's getting stronger.
Pardon me?
It's getting stronger.
It is, isn't
Like at first.
it? My allergies?
No, it's not.
Is there any questions? Because we can just finish early, because it is fun.
Yeah.
All right? Hey, guys. See you at the quiz.
We died of the student loans getting raised.